So this one's going to be over unit 3 and 4. Okay, so first one was matter. So this one was the one where we did the separation of matter lab. Okay, so remember you did it by physical means. So you did a little filtration, then you did a little, you used the magnet, and then we used evaporation. There's just those 3, okay? All right, so given the diagram for matter, fill in how it can be separated. So if it can be physically separated, what do we call that? Mixture. Good. If it cannot be physically separated, what is that called? So it's like waters. No, so that's down here. What is? Give everybody a chance. Okay, compounds and elements are called this.
Something solution.
No, something substance.
Pure substance.
Yeah.
I heard something.
All right. So real quick, since I already filled in that one. So your pure substance cannot be physically separated. So you cannot go do evaporation or distillation or any of those things that we learned about. Okay? You have to use electrolysis or a chemical reaction. Okay? So if you can decompose it chemically, that's your compound. So an example of a compound could be something like some water,
Salt.
CO2, salts, any of those. Okay? Those are all compounds. Elements are basically you pull something from your periodic table, okay? Or your diatomics. You can. I said with electrolysis and chemical reactions. Oh, if you want to get crazy, wear the crazy suit. Yeah. Okay. All right. Now let's talk about our mixtures. If it is uniform, what do we call those types of mixtures? Homogeneous. Okay, so homogeneous, and then if it is not, we call those heterogeneous. Okay. Uh-oh. All right. Homogeneous things are also known as solutions. Okay. Your heterogeneous is split between suspension, and colloids are actually heterogeneous, but they appear homogeneous.
What does that say?
Suspension.
No, the other word.
Colloid. It's in the next sentence. All right. So suspensions and colloids, okay? So the Tyndall effect. Who remembers what that one was? We briefly went over it. The Tyndall effect? Yes, so something like milk. Okay, so if you were to shine like a laser beam or a flashlight, it would spread your light particles. That's why you don't use the high beams in fog. Okay? So Tyndall effect, just for y'all's purposes, just go ahead and write down.
You don't use your brights.
You don't use your brights.
Because then you can't see.
That's what I said.
Yeah, I know. That's
Oh.
I was
Okay.
relating it to that. Because I went driving yesterday.
You made me forget what I was writing. Okay, spread light particles. And the ones that exhibit it are colloids. Okay? A suspension will exhibit it while it is stirred up, but those things end up settling. Colloids never settle. Okay? So the best answer here would be colloids. All right. What are the signs that a chemical reaction has occurred? So we went over this on Halloween. Good. So change of color. A temperature change. Good. Precipitate. That's my favorite. A precipitate was the yellow thing we made. The yellow swirly. So it's a solid from liquids. Okay, so I mix 2 clear liquids and all of a sudden this solid forms. Okay? It kind of looks like a little cloud inside of it. All right, and then gas. Bubbles. Bubbles of bubbles of bubbles. Okay, and somebody said odor, and that's correct also. I'm putting that kind of under gas though. Okay? Those are the forming ones. All right, so now let's go through this little list. It says, list them as a physical or a chemical change, okay? Remember, physical changes, does it change who you are? No, chemical changes completely change what it is, right? So physical changes are like changes in states of matter or dissolving, all that kind of stuff, okay? So a solid was added to water and mixture was stirred until the solid was no longer visible. Which one is that?
Physical.
That is physical. Okay, because this is dissolving. Okay, and that's the one that a lot of people have trouble with. So physical for that one. All right, this one says a piece of metal was, I'm sorry, I wrote this at like 2 in the morning. All right, was added, it's supposed to say was added, but it says wadded. It was weighted into it, just walked in. All right, to a liquid and bubbles formed on the surface of the metal. Chemical. Bubbles, sign of chemical change. Okay, a white solid was exposed to ultraviolet light and it turned brown. Chemical. That's a color change. And then finally, 2 clear liquids were mixed and a yellow solid formed. That one's chemical. That's the one you guys saw.
Wow.
It was lead iodide. In case you were wondering. All right, cool. All right, so what is an example of an intensive property? So before I even go into that, okay, both of these can only be talking about what type of property, a chemical or a physical property? Physical. Only physical. I'm really going to have trouble writing this. There we go. All right, so it's only talking about physical properties. So intensive versus extensive. What's the big difference between those? Depends on amount, right? So extensive is the one that depends on amount.
Intensive depends on the identity of the substance.
Right. And this one is identity. All right, so what are a couple examples of some of those? Intensive. Density is one.
Color.
Color, boiling point, melting point. Okay. Extensive properties.
Weight.
So I'm going to put mass.
Wait, what are the BP and
Boiling point and melting point. So mass, volume. That's kind of all I can think of at the moment.
Yeah.
Okay. You get the idea. All right. Which are intensive properties? Solid. Say yes or no.
Yes.
Yes. Mass. No. Density. Melting point. Okay, good. All right. Number 15. Label the following as physical or chemical properties. So remember the big question that I've asked. Actually, let me turn it. Hold on. There we go. All right. So the big thing that I've told you to ask yourself is it talking about how it interacts with something? Okay. So chemical properties are how it interacts.
Yeah. Everyone's gonna hear I quit, guys.
No, that part didn't. I accidentally pushed the upload button. I was like, really? All right. So how it interacts with something. So if it's not answering that question, then it's a physical property. So fluorine atoms gain an electron when they react. That's chemical. It's how it interacts. All right. Liquid helium changes to a gas at negative 269 degrees Celsius. That's physical. What is that? What's that defining? It's changing to a gas. That's your boiling point. Okay. Letter C, sodium and water forms sodium hydroxide. Chemical. Hydrogen gas is very flammable. That's chemical. It interacts with fire. Okay. All right. Letter E, the mass of the sample is 18. Clear liquid. Density. Melt. Nope.
Physical.
This is the melting point. Physical. It can be decomposed. That's chemical. All right, there you go. Cool. Okay. All right. Next is Unit 4 stuff?
No.
Not yet. Oh, one more question. Sorry. Okay. All right. Number 16. How are mixtures, solution, and compounds different? All right. So go ahead and read through the answer choices yourself. Just kidding. We're just gonna fly through this. All right. Letter A. Sorry. Just want to get it done. All right. So letter A says a solution may contain many kinds of atoms. Is that true or false? That's true. That's fine. Okay. A compound contains 2 kinds of atoms. No, it's not limited to 2. All right. B. A solution may be heterogeneous. That's true. A compound can be heterogeneous or homogeneous. No. All right. A solution can be separated by chemical means. No. That's physical means. Okay. And a compound can never be by physical. All right. And then the composition of a solution can vary. Yes, that's where we get like 95% rubbing alcohol or 50%, right? The percentage things. And then the composition of a compound is constant. So is H2O ever H2O2? No. One is water, the other one will kill you. Hydrogen peroxide. Okay. One you drink to live, the other one you drink to die. That just got very morbid. All right. All right. Moving on to Unit 4. Make sure you look through your notes. There will be particle diagrams, so I would look at that page where we did a warm-up every single day on the particle diagrams. Just know the differences between like states of matter and compounds versus mixtures, okay? So when I say particle diagrams, those were those little squares with the little dots and stuff like that we warmed up with, okay? Okay, make sure you study them. All right, a certain electromagnetic wavelength has a length of this, frequency of that. All right, so before we even do this, turn your paper sideways again. We're going to write our 2 equations down so we make sure we have them. But we do know they are on our periodic table. There is no excuse to not ever answer these questions. Okay. I was grading some papers and I got very angry that some people didn't even attempt them. That's just sad. All right. So it's this. And if you want, this is the one that looks more like frequency. Okay, if you want to use the F, it's not going to make me mad. I don't care. Okay? And then you have the energy one. Okay? And our 2 constants here are C and H, right? C happens to be your speed of light. So that is the 3 E8. H happens to be Planck's constant. So 6.63 E negative 34 times 10 to the negative 34. Okay? No excuses not to answer these questions, you guys. Say that again? Okay, so we're going to flip this sideways again. Let's look at this. I am not going to calculate these for you. I think you guys should be able to handle that. I'm just going to give you the layout. Okay, so the first one says a certain electromagnetic wavelength has a length of 4.10 times 10 to the negative 7. Sorry, that wasn't an exponent. What is the frequency? So we're looking for frequency. They gave us wavelengths. Am I using the C formula or the E formula? C. So you should be using this one. Okay, who are you solving for? Frequency, this guy. Okay? That's kind of the V thing, by the way. Don't write an R. You'll confuse yourself when you look at it later. Okay? All right. What is the energy of light that has a frequency of 7 times 10 to the 14th power? Okay? So it's asking for energy, giving you frequency. Which formula do we use, E or C? E. So this one's going to be E equals H times that little thing. Okay? And you are solving for E on this one. Okay? All right, number 16 is about our electromagnetic spectrum. So remember, our saying is a little, they usually when you get these kinds of questions, they provide some sort of a visual on it. You don't really have to have it memorized. But the reason I made you guys memorize it was so that you knew where frequency and energy fell on it. Okay? So remember, it was the rabbit's mate in very unusual exotic gardens, right? And our color spectrum goes where to biv in that order. With that order, the importance of it, okay, is if you write the word few on both sides, which side has the high energy? The gamma rays or the radio? Gamma.
High energy and high frequency.
Good. High energy, high frequency. So these guys have to be low, and we know wavelengths are always opposites. Good. Okay. So you guys can do that. And I will post the key for these questions later, okay? All right, so the next one says, according to EM spectrum, as frequency increases, energy increases and wavelength decreases. Good. All right, the light emitted from a flame is produced when electrons in an excited state. This was the most missed question on your last test, by the way, so we're do this one. I'm so mad. All right, light emitted is when the electrons do what? They release energy and move down. Okay? Lots of people said moving up. And that's not what it is. It was absorbing that heat. It got excited and it had to drop back down to stability. So it released a little color. Okay? All right. Any questions on Unit 4? Okay. So